Basics of lasers and laser light. LASER is an acronym for Light Amplification by Stimulated Emission of Radiation. The stimulated emission process is the process that creates laser light. The radiation in lasers is just light, but it's a unique kind of light that creates unique hazards. Light is an electromagnetic wave. The wavelength is the distance between two peaks on that wave. Different wavelengths are seen by the eye as different colors. The entire electromagnetic spectrum extends from gamma rays on the short wavelength end to radio waves on the long wavelength end. Visible light is a little slice in the middle. Shorter wavelengths than visible are ultraviolet, longer wavelengths than visible are infrared. Lasers operate in the ultraviolet, visible, and infrared portions of the spectrum. When energy is added to an atom, some of the electrons in that atom move into larger orbits. Now this is not a stable situation, and those electrons are going to drop back into smaller orbits and emit photons of light. Ordinarily, this process happens spontaneously, resulting in light of many different wavelengths that travels in all directions. In the laser, the excited atom is struck by a photon that stimulates the emission process. When a stimulated photon is emitted by an atom, it is identical to the incident photon. That means that the two photons have exactly the same wavelength, they travel in exactly the same direction, and their waves are locked in step, so they wave together. This leads to the unique characteristics of laser light. Laser light is monochromatic. That means it's all one wavelength. It's very directional. It doesn't spread out very much. And it's coherent. That means all the waves are in phase. Ordinary light lacks these characteristics. This combination of characteristics means that laser light focuses 100 times better than ordinary light.